Alright, let's go to question 5. Okay, the rate of change of position, bracket, velocity, close bracket, of a racing car traveling down a straight stretch of road is given by dx delta x over delta t equal t bracket 60 minus t close bracket. Excuse me, where x is measured in meters and t in seconds. A. Find the velocity when t equal to 0, t equal to 4. Now that's easy. Now for those of you who doesn't really do physics, all right, because I do. Now if you find the rate of change of position slash displacement, that will give you an object's velocity. So if x is representing us, sorry, let me change the code. Yep, if x, let me see here. If x represent the distance or the position slash distance slash displacement. So these are some of the words that you might hear a lot to describe. Right? Then the change of x with respect to the change of time will give you the velocity of the object. All right, having that cleared. So you say the first one, find the velocity when t equal to 0 and t equal to 4. Well, that's easy. The velocity function is just right before us, right? So dx dt is equal to t 16 minus t, right? So the first one is 0 and 4. So when t equal to 0, right? So the velocity will be dx over dt equal to 0 bracket 16 minus 0, and that will give you 0 in total. All right, 0 meter. Oh, unit is important. Let's see. Measure in meters. Yep, meter per second. All right, so because it's the rate of a distance, which is measured in meter, over the rate, the change in the time, which is seconds. So meter over second, meter per second. So we've got that. Let's do the other one when t is equal to 4, I believe. Yep, 4. Alright, so dx dt equal to 4, 16 minus 4. So dx dt is equal to 4 times 12. Alright, so there we go. Dx dt is equal to 48 meter per second. Alright, it's easy. Warming up question, as always. Alright, second one. Determine when the maximum velocity occurs, and then the maximum velocity. Right, so first we have to find the maximum velocity. When does the maximum velocity occurs? Now, the velocity equation is given by dx dt is equal to what was it? T minus 16t. T times t 16 minus t. All right, so the maximum velocity happens at the turning point of this particular graph, right? So let's expand the graph, expand the function or distribute the function into it. So it will give us 16t minus t squared, right? So let me rearrange that. So that's dx dt over here. Let me, rearrange it into something that we're more used to. 16 plus 16t. So we know it turns into a quadratic, right? And this is a negative quadratic as well. So, well, okay, this is a positive quadratic, right? Positive x squared will give you something like that. Therefore, negative x squared will give you something like this, which there is a maximum somewhere. So that would be the turning point. Now, how do you find the turning point of the velocity function? If you remember, you know, some of your grade 11 maths, you find the turning point by finding the gradient where of that curve is equal to 0, right? So that's the turning point. So we have to further derive this particular function. All right, so we go now, since the x dt is a velocity function, so if we derive it again, it will be the delta v, the change of velocity with respect to change of time. So literally we have to derive it again. So it becomes negative 2t plus 16. And we know the maximum speed happens when the gradient is equal to 0. So the gradient equal to 0 is equal to negative 2t plus 16. Right? So we rearrange it. It becomes 2t equal 16. I'll just move the 2t to the other side. From negative, it becomes positive, and then t is equal to 8 seconds. So right now we know the gradient of the velocity function, so which is something like this. All right, the gradient of the velocity function is at 0 at t is equal to 8. So all we have to do is just find the t value. So I think that answers one of the questions. So when the maximum velocity occurs, the maximum velocity occurs at the eighth second, or t equal to 8 seconds. So the next one is the maximum velocity. Well, the maximum velocity is applying just using our velocity equation again, which is the x dt, not the v dt, which is equal to negative t squared plus 16t, and sub in the 8 second, right? So it would be negative 8 squared plus 16 times 8. That gives you negative 8 squared is 64, and negative 64 plus now 16 divided times 8 be 128. Yep, so we do that calculation. Now that is literally half, so it'd be 64 meter per second. All right, that would be our maximum velocity. All right, number C, sketch the graph of dx dt, the velocity graph, against t in the domain of between 0 and 16. All right, when it comes to sketching, we'll turn to decimals. All right, just give me a second, I will put up the graph. All right, here's the graph. So we have to integrate the velocity function over the domain, which is 10 to 0. All right, 10 to 0, so we have to integrate. So integrate. Oh, no, let's do it properly. So we have dx dt is equal to t squared plus 16t. So we're trying to integrate, which is a definite integral, 10, 0. So you always put the later one, the further, the bigger x on top and the smaller x on the bottom. And so that's a function. And then since we move the t to this to the right hand side, so we go integrate with respect to t. All right, so this side we get x, and This side is easy, so it's just t cubed over 3. So this is the reverse of the power rules. So the power increased by 1 and divided by the new power, right? And then there's no plus c here because it's definite integral. So we got 10 on top and 0 on the bottom. Very good. Now all we have to do next is just sub 10. Right? What we have to do is just sub 10 into the st in the first function, and then minus sub 0 into the t again. Alright, so by what I mean is this. So first we have to put 10 here, as t, and then with the minus the whole thing with 0 in it. That's what we call definite integral. And then let's calculate it. So 10 to the power of 3 is just 1000 over 3 plus this. Now this is 100, so this is 1600 over 2 minus, that's literally just 0 plus 0, so the both side is gone. Right, rightio. So we get, let me use my calculator. 100 divided by 2, divided by 3, 1000 divided by 3, plus literally 800. So we get 466 and 2/3. Now I remember our x is measured in meters, so obviously in here we'll have meters as our unit as well. So 466 and 2/3 meters would be our answer for D. And then E, what does this area represent? The area, we'll look at it. The area has a unit of meter, so it is definitely distant. So since this distance is since the area we got is from t equal to 10 to t equal to 0, from t equal to 10 and t equal to between t equal to 10 and t equal to 0, that would mean that's the total distance, right? The car has traveled from 0 seconds to 10 seconds. So the area in there means the total distance traveled by the car within the given domain, 0 to 10. So that's what it means. So this distance or position, that's what the question addresses us. This distance slash position is the total distance. Why am I writing displacement? It's the same thing. Well, not really, but you know, the distance slash position traveled. Now the position one doesn't really work here. Let's just stick with distance. It sounds awkward if it's position. So it is distance traveled in the first 10 seconds. Yep, so the mic, something went wrong. 10 seconds, so that's, yep, the distance is the total distance traveled in the first 10 second bracket from t equals 0 to t equal to 10. So that's what it means. All right, that will conclude question 5. Yep, as usual, let's head to commercial break before we head into question 6.